data flow and business flow, same thing. Which way things are going to make sure things are used with their full capacity by anybody who's interested to play in this space. Next slide. Okay, now, what are the key technologies we need to build the energy internet? So on the top line, the blue boxes, holographic perception. Holographic means it's three-dimensional. You have to see from all angles. In this case, 3D doesn't mean height, length, and depth. It means the time, the quantity, the location, the seller's history. That has to be available. In fact, as you know, in Amazon, I see when I buy something, I get the seller's history. I got 3-star, 4-star, 5-star. So I usually use that to make sure, should I buy from this seller? That's what I mean by holographic perception. Ubiquitous connectivity, just talked about that. It is there, unseen, unknown. And integrated innovation. We innovate a lot of things. You got supply, demand, the transaction of in the network, the product quantity, product price, product availability and time, all that has to be worked in one platform. So for that to happen, these are the orange boxes, number one on the left. For that to happen, we need intelligent sensors and terminals to get the data. We must have real-time communication capability for the network and an IoT platform that will bring everybody together. And all that has to be underpinned by information security so that all these transactions can happen without any interruption. Otherwise, people will lose faith in this. So that's why I put as a foundation characteristic, information security. Next slide, please. So for that to happen, we'll need, most of you know this already, we need an ICT framework. At the top, I have edge devices, routers, the gateways. In the middle, we have smart meters for buildings to help us collect information. And then inside the house, inside the building, we'll have home area networks so that if you think about this, it is possible for, if the power company is monitoring my demand in real time, every few seconds, they can tell what I'm using. I'm using my refrigerator, air conditioning, electric heater, whatever that is. So I don't want that information to be known to the power company for privacy reasons. So inside I have a home area network, which will keep track of things. But for the power company to see is my combined load. They would not see the individual loads. This is the job of the home area network, to keep the data flowing among various devices, but not that level of granularity be visible to the power company. Next slide, please. Okay, now, field implementation. How would you do this? Let's start at the top. We have control devices like smart switches, smart thermostats, my in-home energy management system. That's the control devices. They will interact with the electric meter through the EMS software, sensors, data gateways, and then customer is the homeowner, building owner. They have an electric meter. Then that electric meter is seen by the power company through the network, landline, and so on and so forth. In Virginia, my house has smart meter. How does it work? The smart meter broadcasts data using microwave. That data goes to a data concentrator. In my neighborhood, maybe 100 homes are doing the data transfer using microwave. That data concentrator collects that information and sends data to the nearest substation using GPRS, cell phone network. And then from substation, the power company control center, they use their own fiber optic line. So that's the network in my case. So first is microwave data transfer, then GPRS cell phone network, then they own fiber. So you can decide which makes more sense for you and all that going forward. Next one, please. Okay, now talking about we said energy flow, data flow, business flow. Now the business flow part I'm talking about. So we have possibilities. Usually in my model, we do 1 hour ahead offer or forecast. So between 12 to 12:59, the offers being made. Somebody wants to sell at between 1 to 2 o'clock, 1 hour from now, 6 kilowatt hour at 3 tokens per kilowatt hour. That could be dollar, could be RMB, could be whatever, rupiah, doesn't matter, just some tokens. There's a selling offer. Buying offer, somebody wants to buy 5 kilowatt hour at 4 tokens, buying price higher than selling price, that means it'll go through. And then the distribution system operator, like a microgrid, they have some pricing offers that they would not allow the price to go over 8 tokens per kilowatt hour for prices. And then some building wants to buy some energy at 4 tokens, not 3. So I've got 2 buyers here. Both of them want to buy at 4 tokens on seller, and DSO is not buying on selling, keeping track of things. I have now 5 plus 5, 10 kilowatt hour to buy offer, and 6 kilowatt to sell offer. That means my buying offer is more, buying demand is more than selling offer. So I cannot meet buyer's demand. That's the challenge now. That get posted. Then they will negotiate among themselves. Only 6 kilowatt to sell. Demand is 10. So demand is 10. So who gets how much? Those are the transactions we'll go through. And I'll show you an example later on. Next, please. Here you go. Right. So how we do this? At the bottom, I have wise market. Wise market means this is the market where the buy and sell offers have been posted. Then I got different options: PV trading, demand response trading, and data analytics. What I mean by PV trading, this is a transactive energy platform inside a microgrid. There are many homes and buildings which have rooftop solar. So they will use this platform to transact among themselves. That's PV trading. Demand response trading, you saw before, we have 10 kilowatt hour purchase requirement, 6 kilowatt hour selling. That's 4 kilowatt hour short. Somebody might say, okay, I see there's a 4 kilowatt hour demand unmet. I am a building owner. I'll reduce my consumption of the air conditioning, let's say, for an hour, and I'll save 4 kilowatt hour for the next hour. I can put that on the platform so that power company can save 4 kilowatt hour from my building, and then they can sell back to the 2 buyers who wanted the additional 4. That's DR trading. And of course, data analytics, you keep track of things, is understood. So Wise Market keeps track of these things. What makes it possible? On the top, the pink line, Wise Building, Wise Grid. Wise Building is the platform that we talked about before. Inside a building, will keep track of the building demand, building storage capacity, building capability to change, reduce demand by changing thermostat setting or dimming lights, all that. And Wise Grid is the network information which will make sure that if multiple homeowners selling PV power, that would be possible because of the local circuit has capacity. So I have to move on because time is short. If you want to know more, this information is available from this company called BEM Controls. There's a website. Go to their website and see how things can be done. So let's move on. We're slow. Okay. This is an example. We have a research project now with a power company in Chicago where this will be deployed down the road. Now we're doing simulation work. So what I've just said on the previous slide is summarized here. On the top, you got Wise Grid, Wise Market, Wise Building, all happening going on. By the way, I think these slides can be made available to you. If you can do more work later on, it can be found there. And at the bottom part of the screen is the Chicago Bronzeville microgrid. That thing's real, that exists. It has rooftop solar, storage battery, it has different buildings, it has controllers, all of that real numbers. So this is happening with this BM Control Company and Virginia Tech to do the simulation right now. Next one, please. Okay, so I mentioned the rooftop solar. That's my building where I work. So this is not something we talk about only. We live this. So now my building has this rooftop solar, which we can transact with the local power company. Next one, please. Okay, now I'm summarizing this. On the top, we have prosumers. What is a prosumer? It is a building owner who consumes electricity and produces also electricity from the rooftop. They're producing and consuming. The new word is prosumer. The building owner on the right-hand side for demand. In many cases, Chicago is an example, there are ground-based solar PV projects to provide power to the network, not just a building. And then demand, DSO, distributed system operator, their job is to manage the system so that every constraint is met. Next one. So again, to summarize, we have a microgrid, which is multiple homes, and then there is demand distribution system operator, TE aggregator, new term here. This means transactive energy aggregator. You see on the right-hand side. It is very difficult for a utility, in my case in Virginia, to keep track of 2 million solar homes. It's not possible. So they will employ an intermediary, call them transactive energy aggregator. They will keep track of 100 homes. There could be 100 aggregators, each managing 100 homes. That's how you can manage 10,000 homes. Power company only see the 100 aggregators, not the whole 10,000 homes. That's the idea. Next one, please. So now coming to the control issues. Active controllers and transactive controllers. Active controllers ensure that customers adjust their energy consumption depending on price changes. This is new. My consumption now is fixed because I know I pay in Virginia 10 cents a kilowatt hour. But if I am given real-time information about the price available to me, I could rearrange my washing machine or clothes dryer or hot water heater, things of that type, to take advantage of the price changes for me. And that's the wise building we talked about before. Transactive controllers, they are allowing the individual buildings to participate in the local energy market by both buying and selling offers available from an open platform. That's transactive controllers. Next one, please. So this is an example of how we do this. We have done this work. And again, before I say much more, if you want to know more about this, two sources. One is open source software platform available from bmos.org website. One of my students who's back in Thailand now worked on this one. And then this is open source software, which has some basic functionalities, which you can download and deploy yourself. And other one is a commercial software platform, bemcontrols.com, where you can go to website and see how they can help you if you're interested in this. Anyway, so on the right-hand side, I have different characteristics: occupant comfort, distributed energy resources, sensors, power meters, plug load, lighting load, HVAC loads. All of that information is available for any and every building. That information is posted on the Wise Building Cloud with some security, of course. And then we have DER owners, distributed energy resource owners, who can buy and sell. All of that is on the internet. And thank you. And then internet also is accessible by the distributed system operators, so they all work together. Next one. So this is an implementation of the idea. You have a home which has thermostat, dishwasher, refrigerator, water heater, maybe fuel cell, battery, and then a gateway to collect information from all these devices in the house and make it available to the power company if they want you to sell or buy at a given price. So we have air conditioner on the lower right. We may have rooftop solar. We may have wind from this field application. So this is the example of how we will implement what we talked about. Next one, please. Okay, now summarizing everything now. WISE Building it is a open architecture platform. It can do control monitoring. It can extend to solar PV and storage, and it helps buildings to participate in demand response programs. That's WISE Building in your house. WISE Market is the local energy market platform. It has secure record of person-to-person networking. It has some building algorithm that you can use to bid, like I said, 4 tokens, 5 tokens, 6 tokens, and automated transactions. Nobody is sitting and watching how much buying going on, how much selling going on. You put the offer, if it matches, transaction goes through. That's the WISE Market. The last one, WISE Grid, is a microgrid energy management platform. It can do monitoring and control at the system level. It can have programs of pricing, offer, buying restrictions. It can do demand response. And of course, it can do data analytics using information from the cloud to see when people buy the most, when people sell the most, when is the price highest. If that information is made available to the future users, they can be more intelligent in the transactions. So all that added is what we call energy internet. It can be used by homeowner, utilities, microgrid operators, that allow you to transact on a common platform. It can fully integrate person-to-person or business-to-business transactions, and it can make demand response more practical. Again, this is the concept. We have papers on this topic. Again, the website at the bottom, BM Controls, it has more examples of how this is accomplished. So next slide, I think last slide. That's the commercial for today's talk. As some of you know, I'm running for IEEE president. My website is there, srahman.org, also on Facebook. And as Naga said before, I was the president of PES 2018-2019. I served on the IEEE board. And with your support, especially PES folks, I have done 3 things. We have built PES University, and Dean knows this very well, where we are providing learning content for PES members and everybody else. If I become IEEE president, I would like to make PES University grow into IEEE University. I've also done PES Corporate Engagement Program, where we have a program through which companies can pay the dues of their members, of their employees, and get some benefit from PES. That can be extended to IEEE level as well. And something I'm very proud of, I formed what is called PES Chapters Councils. We've done that in China, India, Africa, Latin America, where the chapter chairs can get together and do programs on their own so that they are more visible, more effective, and more able to do things they want to do. Before, that was not possible. China has 9 chapters, India has 10 chapters. Now they have a budget in India, China, Africa, Latin America, whereby they can travel within the region and do special programs. China, India have done that already multiple ones. And now I know Dean has talked about this.